Welcome back, guys. Okay, so another week. So, where did we leave off last week? I guess we were trying to figure out why which IO was not able to. Why I'm not able to read the which IO specification 2, that is 1.2, because I was just getting version 1, and I was hoping to find how we can switch to the newer version, because all my implementation is already based off the newer specification. And a general overview is that we've been trying to get get add-on support for file system for my kernel. And to have the file system working, I also need VFS layer and block layer. So because I'm dealing with block devices, and every device might have a separate implementation, so the block device layer is gonna abstract away that, so the VFS layer can just call block read and block write, and internally all the stuff is going to be handled. And currently we were trying to rewrite that layer, and it's this which block, and our actual physical requests are sent to which IO, which is Camus, which is what we are our setup, which is Camus is using. And as a driver to talk to the device, we send requests via virtuio. So that's what we have been doing. We were going through the virtuio specification, and it clearly fucking states that virtuio 101 should return 1 2 here, I guess, because legacy devices would return 1. And when I try to build it, okay, what is this? Yes, it's some V8 stuff. But when we run it, what we get is that we get version as 1 as in 0x1. That means it's a legacy version. I mean, we can implement the legacy version, but then I want to actually implement the version 101, so that it will be, it's not legacy and it's supported right now. And there is a new version which I specification 1.3, I suppose, but still, at least we'll first start implementing version 1.1. And also because I have already invested a lot of time into understanding how this version specification works and what exactly to do with it. And now going back to version 1.0 would take X time, which I am not fucking interested in investing. So let's see. And we were actually stuck by the end of last time, because when I actually tried to see how I can actually fix this thing, I had no fucking clue. So yeah, still now I don't have any fucking clue. And the entire week I did not even think about it. I just dropped into this from 1 week of no context about this problem. So right now I have lost even more context of what I was trying to debug. I hope there's a good to do for me, but I just remember that I need to switch this version, because here, as you can see, we get this error as queue not ready, and the version is 1, because that's a check we have. Here we get the status. We put in saying that we want to select the 0th index as a queue, and that check works fine. And then we try to read the max number. If, as per the specification, if the queue is ready to be used, it would return some other value, which is the max size. But currently I'm just getting 0x0. That means the queue is not ready. And when I try to debug this, I figured out that specification, specification does not, specification 1.0 has a different way of doing it, and we can't simply do which.io 1.1 specification when the actual device is 1.0. So then I want to actually change the specification, but right now I'm completely clueless, because I don't know how do we change it. Because here we are saying that we want which.io block device. That's all there is. There's no way to pass in what specification to use. Maybe we can overwrite this specification. This is what I have to look into. What exactly? Ooh. Okay, what we want? I have a Kernel setup with which.io BLK, and when I try to read the version which.io, it returns 0x1, which is legacy. I want to use which.io 1.1 so that it would return 0x2. Okay, so what exactly should I change? Because is it my camo flag or should I directly interact and update the version? Or is there any other way which I am completely clueless of? I was listening to too much TikTok and Reels, so my head is just running into this small bits of songs. Yeah. Value 0x you are reading from which.io version register indicates that your device is operating in legacy fucking mode. Okay, fine. Now confirms the older version of you want to upgrade to modern and later. Where the version written okay, whatever. Now, so let's think about it. By default, Camus emulates legacy devices for maximum compatibility with older versions. So use non-standard MIMO register layout, lacks standard bits. Use standardized PCI-based switcher reports version 2. Force Camus to expose modern virtual so the guest reads version 2. Yeah, that's what I want. Okay, so how do we do that? You do not update the version from inside the guest or via version directly. Instead, you configure Camus with I fucking tried this, it didn't work. Okay. use which I will cover but I am in ARM Camo setup, so does it have PCI at all? This is my fucking Camo setup. Holy fuck. Okay, so we have Camo magician, okay, whatever. Using build device which uses memory maps, not PCI. This normal experiment. Okay, fine. I'm fine with it. So let's see how we can change that fucking thing. So we change it to PCI and set legacy on. I tried this fucking thing, it didn't work. And ensure your guest kernel supports. Oh, config PCI. But my kernel is my own. It's custom from scratch. So if I could spell it. What do I do then? I don't have any PCA support yet. I am writing the block layer now. That is why I am trying to connect to the rich IO in the first place. Camo can emulate modern, but is disabled by default. You set device fuck, it does not work, and then you see it is greater than, and I'm sure it is fucking greater. Oh, like that. Oh, fuck me. That's the same fucking thing I tried. I don't want to fucking try the same thing and again and expect the results to be different. Disable legacy on. Oh, let's talk. And it says device not fucking found. You fucking piece of shit. That is not even a part of the fucking thing. Find an article about this. Some what the fuck is this? Global. Is that even a thing, or did you just fucking whatever you fucking hallucinated? I don't know. Looks like it is an option. So maybe it will work. So I keep my old setting as it is. which is I have a drive and I have set the device as this, and I set a global setting saying that the legacy virtual should be false. Okay. Ooh, did it work? Oh, it fucking worked! Oh my fucking god. I cannot believe this. I cannot believe this. So let's just write the comments somewhere. Okay, let's just write it here. Gen by default, Camo does not runs on legacy modes. So make sure you disable it. But to do that, we might have to pass global parameters. Wait, let me confirm one more thing. Okay, it fucking worked. Well, fuck it, my mouse pointer, if I could fucking see it. Okay, it's here. Okay, so it worked, but now my question is, so because which IO BLK device does not have this option, we have to pass it via global. How does Camo overrides it if the actual thing does not have that option to start with? So as I say, which block device does not have that property, then how come a global property is able to fucking override it? That's my fucking question. See, let's see. What's our thoughts? Some memory mapped is defined will not be. Okay. Okay. So we are actually passing in a variable for which MIMO, not for which block layer, because this is something that I actually wanted to understand, because in this article, which IO has multiple layers. It's like the device type that we support, and here we are saying it's a block device, and block device can also support multiple transports, PCI and MIMO. Here, as per this solution, we chose device as BLK and we chose transport as MIMO, and this MIMO layer has this force legacy. At least that's how I'm gonna take it, and I'm gonna move on from this, because last week I was fucking tired of trying different options, and last time it did not say anything about global. It just kept saying fucking you add this other things, and then I was trying to see why those flags were not available, and then it turns whenever I Google it says that those flags are valid and it's not fucking hallucinated. So it was just so fucking annoying. So somehow we had a good day. Probably I don't know how. I was thinking like maybe I'll have to go through this entire session just about finding how the fuck am I gonna fix this which specification issue. Well, whatever. Good thing we didn't have to. But still we get queues not ready? What the fuck? That does not make any sense. We have the ready status, we have the version as 2, and still the queue is fucking returning 0. Okay, now we have an issue. Okay. At least we have crossed something. So it's fine. It's not bad. Okay, here we are. We're trying to read the which IO max, and we get 0. And let's do this. Let's just remove these things so that it won't interfere us. And let's simply kill it, queue it, and also make sure we kill this, and we build it, and we want to break it in it queue, and let's just 1 2 3 4 1 2 3 4, and run it, and we stopped. Okay, so we are now within that function, and let's start by writing 0 into which queue cell. And okay, I believe this is gonna do that, and we return. And then what are we writing? I think then next we are reading something. And then we try to read the device version. After reading the device version, we try to read the max queue size. Okay, this is what we have to work on. It's going to be this call, and it is its first argument should be this, and the second argument should be the max queue number. Okay, let's just print x1. X1 is 34. Why is it 34? Yes, it is 34, so it makes sense. So everything is fine. And here we move one step at a time. Okay, we try to move something into x0. What the fuck is x0 now? X0 is something which is this, and I guess that is our base address. I think so. Where the fuck is it? I think it is our base address. Yeah, it's our fucking base address. And we have x1, which would be probably 34. So we are going to read x0, right? x0 plus 34, and it is 0. What can we say? It is fucking 0. Right? We have to read from the value within that. Maybe it's just my calculation that is wrong. It should be done properly by this anyway, because it's just read. It's going to dereference whatever offsets we get here. What? It's going to be which are your base. Okay, from my context, I'm inside a virtual space, so I have to dereference this base address in my virtual space plus the offset and read it, so it's fucking correct. No fucking clue. So whatever it is, let's just see. I don't know, man. Oh, fuck it. Oh, we have the read u32. We pass in the objects, and we pass in the index, and that fucking index has 0 in it. Why is that? If we have 4, I think let me just put this, it'll be far simple. Plus 0x34 and a 0. So what can we do is that let's just type 10, 50. We have the magic number, we have the version, and we simply have zeros. We select the which queue by setting 0, and which select is that, okay, and then we read it, reading is just going to give me something, and then we read the version. What am I missing here? Maybe it's just select the queue, writing its index to queue cell. Check if the queue is not ready. Use qpnf expecting a return value of 0. So Q is ready because this condition is not equal to 0. And what did we get as status? Ready status is actually 0. So the issue is actually here. The ready status should be, oh, expecting a return value of 0. So this is returning 0. Okay, fine. And read the max queue size. Okay, let's try 1 then. Let's see if any of the queue is available. Ooh, Q1 is available. Or is it just that we don't have the sprint? Okay, fucking Q1 is not available. Let's try Q2. Not working. Let's just put it 12. We have 12 fucking queues and nothing is available. So it's not availability that is fucking issue, it's something else. Oh, am I gonna fucking figure that? So when I read from it, get 0. So what are the possible things that I need to check to confirm if the queue is actually not ready, or is there anything else that is going wrong? Did I do that? I think I did. Yeah, I've reset it. And then I sent acknowledgement. And then I sent driver. And then I said feature okay, because I didn't set any features, but I just said feature okay. Maybe that's the issue. Let's think about that. And then I said finally driver okay. And in queue select, let me just write 0 again. And I try to read QNUM max, which is then fucking not. Okay, that's not fucking doing anything for me. Okay, let's just see if we actually have to set any. Okay, so in my case, I am resetting it and send ACK and send status driver, and then I send features is okay, but I don't select any features. Is it necessary to select a feature? Whatever that means. Oh, you must select at least one. It was not told to me that way. I'm not even writing features. Huh, okay. Ooh, it is specified here at least one. Wait, let's double check that. At least once. Mm. Nope, I didn't understand. Mm. During initialization, driver allows the following sequence: device status. We say acknowledged. Okay. During device initialization, the driver reads this and tells the device a subset. What if I don't do it? It's not specified anywhere that it's a must. What if I don't do this? There's nowhere it says it is must. Okay, at least we have to write 0. Maybe that's the fucking issue. Well, it's possible. So let's just fucking write that. What is it? Device features. Do I have it? Okay, I do have it. Device features and device features select. So I have two things. Let me go back to the specification. And let's see. No fucking clue. It's just that magic. You should be able to come back here. Okay, device features. Read from the register, return 32 consecutive flag bits, the least significant parameters. We read from this and we write to this, so it is correct. That's the correct order. And where are those bit specifications? Okay, which bit should I write? I want a block device access, not net device. So what? How do I interpret the bits? Which bits? What? What are those bits? What are those fucking bits? What? I have to write into device features? That doesn't make any sense. Oh, I'm confusing device features and driver features. We read from device features and we select the driver's features and finally write the driver's features. Huh. But where is this information given in the specification? I didn't see fucking thing. Huh. It fucking hallucinated. What the fuck is this? Let's see what is 33. I want block device access. So what feature should I write? No, I have no fucking clue. Huh. Maybe first of all, let's read what are the bits that we can actually get. So I have device features and device features select, and I need driver features and driver features select too. Driver features is 0x20 and driver features select is 24. Okay. 0 to 31. If we set device feature selects to 0, if we set it to 1, then the features are from 32 to 63. Okay. So first of all, we need to decide we want the upper half or the lower half. But there's no information about which bits point to what. Okay, fucking let's just read from the device features and see what we get. Device features. HIO device features. Okay. Let's see. We'll get a 32 bits integer value. We'll have to convert it into bits. Okay. And device features is fucking 0. Maybe first we have to write something to it. Wait. What's the order? To get block device access, you must accept. This is wrong because this bit is 32 as per specification. Okay. And we are reading from device features. When I read from device features, I get 0. So we start. What? What? Device ID is valid. We have this, but we still don't read device ID. Okay, let's just read the device ID then. Maybe I'm not having the proper device at all. Device ID is 0. Ah, fucking hell, it's wrong. That's why. That's fucking why it's not working. Oh shit. My device ID is also 0. I think I will have to iterate through all the possible devices and then check which device actually has a device ID. Okay, we have to R it. That's interesting. Because in my case, I don't do that. I always update status with one value. So status has to be art. All values, that is ACK plus driver Okay, maybe that is the fucking issue. Okay. Okay, then what we can do is that let's read UN32 current equal to read UN32 HIO object HIO status and then what I have to write is R of current or status. Would it work? But status, this only reset has to always go through normal version. If status equal to reset which I reset status reset. In that case I simply write it. That is just status. Wait. This is status value. I think status value is 0. So if value is 0, then we update status with just 0 and return. If it's not, then we read the current value and we update the current value plus that. Still, it's the same case. Current state is always 0. So something is wrong. Still the current status is always 0. Why is that? Here we are resetting it and then we are writing 1 to it. So it should have fucking updated it to 1. Okay. Whatever. Let's try the other way. We reset it and then we acknowledge it and then we write the child acknowledge and which are your driver, and then we driver and we say driver okay. We say features okay, and we take this put it here and we say here all is out and we say driver okay. Holy fucking okay. That should technically work. Nope, it did not work. Now let's do one more thing. We still have to see if our status is actually updated. Current status. Redo 32 and we pass which IO objects and we get offset which is which IO status. Alright, let's put that after everything and let's see. I believe something is failing in this write. See, nothing was updated. It's just 0. That's just so fucking sad. Okay. So now at least we know we have an error and that's not related to we reading queue number as 0, which we have no idea how to fix if just always written 0. Then the only solution is that somewhere behind we did something wrong and we came back and we figured out that update status does not seem to be fucking updating anything. Or at least in my fucking case, it's not fucking working. Maybe it's because I'm always getting uint 64 values and I'm writing it into uint 32. Maybe. Oh no. Let's try to convert it into 32 then. This should also be 32 and right should be 32. Okay, we have rights which is going to be base plus offset and we take it as U32 and we dereference it and we write it as and write a value into it. And when we read it, we do the same thing. We take the offset, we dereference it as U32 and we get the value. Okay. What is get lower half keyword upper half? What the fuck is that? Okay. That's fine, I suppose. Device ID, device features. Okay. I think rest of it looks okay. Let's just confirm that we want to write I acknowledge and then we write this. Now we have an error. Conflicting types. It says my header file has Still even 64. That should do it. Okay, still no difference. Still our current status is 0 every time we write to it. Now it's time to actually stop here. Where is it? We stop at this init with shared driver. Probably it's some issue with my MMU because looks like that, because I have previously once had a similar situation where I write to some location, write just works fine, but then when I try to read from it, there was nothing there, and it turns out that I was mapping my physical thing into a location that was not even there. And it is possible that I'm doing the same thing here now. I'll probably have to base my vector. So it's like my physical RAM starts from 8,000, some 8 lakh number. So if I write anywhere above it as a physical thing, then my writes will work fine, but when I try to read back it, there won't be anything. And it is possible that I'm doing the same fucking thing here, but let's just confirm that we are trying to write into this, but why it should not be in matter is that because this thing was allocated by this is the base register, and we added a map for it, add which IO page, and we mapped it to what? Wait, this is my virtual address and I'm mapping it to reg, and this reg is supposed to be what? Reg is actually coming from my actual device that I just found through DTD. Okay, that makes sense. Let's just put it here. It's not, it's, this is the physical address that we took from the parse DTD. Okay. So we add a page from our virtual memory, which is FFF860, to this memory mapped register, which is a physical thing. And when I write to it, it works. But when I read from it, I don't see anything. Okay, that is what is happening here. So I parsed my get the register and interrupt number of my moments. So then I write to this, so it works, but and I read back again. The value is 0. What could be the potential things I need to check to verify this happens? Let's see. Did I get blocked device ID is 0? No. Okay. But I do have the HT0 value still. My device IT is 0, but the version and magic is there. Holy fucking moly. How can I put a typo in ID? Fucking hell. Oh, we can do this. That's right. How do we do that? We have to this. No, let's just do this. Let's check what value we get. Maybe that's the best way to debug it. add this monitor CDIO. I don't know if it's going to give me some shell where I can type info Q3, but let's try. Maybe it will work, maybe it won't. There is no fucking thing as that. And that. I have to put the enter here. And I have to put another slash here. Let's see if that is even a valid statement or not. Okay, let's remove this then. Okay, so we have Chemo. And now we have to just type info tree. What? Help. And there is info, and then we want Q tree. Okay. Info Q tree. Now we have a big output. We have to find the proper. We have, okay, this is what we parsed and we try to get something. Okay, so we do have a bus that is there and it is device. Maybe that's the issue. We'll probably have to. But this is what we got. I think I managed to parse this one. And it is HD0. Maybe that's the issue. We have to, because why is all of my MIMOs have the same address? Because here we have a device and it says this is what the first parse string that we use, and within that we check if what do we check? Let's go back to our is it it's here, and if we go into device drive info, what we do is that get the begin token and we see if it is VAR, and then if it is VAR, then we check if it is COM next. The token prof is COM. What? Okay, it's COM, which is compatible, and then if it is actually compatible, then we check if the string is reg. And if it has interrupt. That is all we do. Maybe that's the issue. This is net PCI. And I think ours is, we can, it's just A000. We have multiple of them. Wait. I think that is the issue. Here, if we come back here, where is interrupts? This is the register. And it is A00, which is wrong. It should be probably this. I think that is the value we actually try to allocate. Is the register? That was the first thing that is which I MIMO, and we take that as the actual value. This is the first time when we are passing we reach this which IO, and it is a MIMO and it has interrupts, so we just directly take its output here. I think that's the issue. Q3. In Q3, what we see is that maybe that is the one actually, because this does the one actually does not have any ID. Yeah, this is probably the difference. But why is it that my DTD only sees the address as A000? Maybe one thing we can do is that where is the interrupt, because it does not say anywhere interrupt, right? We have queue size, number of queues. There is no interrupt number. Where did it find actually that? No fucking clue. But for sure, this is the drive, because based on the name, this is the drive. But it does not have any interrupt numbers here. What the fuck? So Camus creates 32 which slots. So we simply try to read all those slots 200, and then we try to see if has a device ID. Huh. It was mentioned nowhere. Okay, what about the interrupt number? Is that even valid? Is 16 valid? Can you find docs where this is specified, like how to get memo address from DTD, as I thought we have to get the reg directly, not anything about parsing, iterating over them with 0x200 bytes each. I never heard that. How did you come up with that? Okay, even here he is doing the same thing. He's just iterating over all the virtual pages. Probably this is why this is even saying that information. Somehow this guy found out this information somewhere. That's how LLM is able to get this byte information. We keep calling device in it, and that's exactly what it's doing. He's checking the magic magic, and then he's checking the version, and then he's checking if the device ID is 0. If it is 0, we just returned. Okay, but I still don't get where this information came from. How did how did those guys find out that we have to go through to the to 0x200 bytes to read one device at a time and check if the value is not equal to 0? This fucking LLM just copied that article, but that guy must have found it somewhere. Where is that documentation? I want to know how the fuck he figured that out. And it still relies on this example. Okay, he has found the steps from the specification, that's fine, but where did he find which I start to end? Whatever. Somehow everyone knew that the entire thing will have 200. Okay, maybe they just figured out it will have 200 bytes because based on this overall offsets. Maybe. So the entire specification has lots of values. So then it should be under 200. Probably it is the entire setup is 200. That's why they just assume that every thing is 0x 200. Okay, maybe I should have fucking used my brain to figure out that part. Okay, makes sense. Okay, makes sense. Okay, next time what we have to do is that to do this, we just have the MIMO starting address. We have to look into all devices from this address with 0x 200 as the offset, and check if the device ID is not 0 and register all of them. Okay. I think at least today we managed to do two things. We managed to figure out how to change the specification to version 2, which was a big deal. I thought that's what I'm gonna do this entire session, but turns out I figured that pretty easily. And the second thing that we figured is that we were using the wrong address. We were trying to read from A00, and the device ID is always 0. So there's nothing happening there. Now, and we also tried to set driver status to 0 and stuff like that, which does not even make sense because device ID is already 0. If the device ID is 0, then there is nothing behind it. And Kemu's, we just have to write that Kemu MIMO will always have this address range mapped, but the backend will not have anything. That is why we need to check if the device ID is set or not. Okay, and this is the biggest realization we had today after a lot of fucking around, I guess. Whatever. Okay. Thank you guys. I'll see you tomorrow then. Bye. That's my